Hey everyone, hope you had a good weekend. This week is exponential growth and decay. We started this, we were finishing this up right when we left 7 weeks ago, believe it or not. But we started off with the original formula, y equals a times b to the x power. The reason this is exponential is because x is the exponent. Quadratic, it's squared. Linear, it's nothing, it's one. But when it's exponential, x is the exponent. And we'll talk more about what all that is and everything a little bit later on this week. But if you talk about what the things stand for, remember that A is always the initial amount. It's what you start off with. Sometimes we could say the principal. All right. B is your multiplier. All right. It's what you are doubling, tripling, quadrupling, whatever. And when we get in the next little bit, you'll see percentage rates, but that's your multiplier, whatever's going on. And then X is usually the time periods. How many time periods happened in the problem? All right. How many time periods? So you got your initial amount, your principal, you got your multiplier, and you got your time periods. So let's go on and look at a couple examples. This is where growth, if they give us a percentage rate, then we have to put the 1 in there because that takes care of the initial amount. Then the rate is the increase. So if it's a growth, it's 1 plus the rate. If it's a decay, it's 1 minus the rate. All right. The formula now looks like this. A is still your initial amount. All right. Rate is still your multiplier. That's your B, and then there's your time period. All right, so everything looks the same. It's just it's just instead of B or instead of a number, it's a 1 plus whatever the percent is. All right, and there's an example of the decay, 1 minus the rate to the x power. All right, just a couple of reminders that when you change a percent to a decimal, we don't do any percentage problems. We have to change them all to decimals. So you move the decimal over 2 places to the left. So 5% becomes 0.05, 10% becomes 0.10, 4.5%. All right. You move the decimal over 2 places to the left, and it becomes 0.045. And I remember when we did this, people were, there's the decimal, it's right there. Remember, it's a percent because of the percentage sign, so you still move the decimal over 2 places. So if we got 0.5%, we move the decimal over 2 places. All right, it's going to become 0.005. Right, 2.5%, 2 places. All right, 0.025. Right, and then 6.92%. It doesn't matter how big the number is or anything like that, you still move it over 2 places, so that'll be 0.0692. All right, so don't forget those little tidbits there. All right, so here's our first example. We've got the population of hometown in 2016 was estimated to be 35,000 people with an annual rate of increase of 2.4%. What will the population be in 2025? So first thing here, it says rate of increase. So there's the dead giveaway. It gives us the percent, so we know we're going to have to use that parentheses with the 1 in front of it. Remember, you never use the year as a time period. How many years occurred between 2016 and 2025? All right, so that's what you got to think about when you think about time periods. So let's start with this problem. I already got the formula written out. So we say 35,000 people. That's our initial amount. That's our starting point. We know it's an increase, so it's 1 plus. You never use a percent. You got to change it to a decimal, so that'd be 0.024. All right, and so instead of 2025, I want to how many time periods occurred. That was non-time periods. That was 9 years. So when you put that in your calculator, all right, you put that in your calculator and you hit enter and you get 43,327. Now remember when we did these, we don't, when it's a real person or a real life thing, we round it we round it down. We don't use a decimal point. There weren't 0.3 people in the town. There weren't 0.5 people in the town. There were 43,327 people. All right, make sure you label it. Doesn't take long. All right. All right. So let's go on to the next one. A radioactive element decays at a rate of 5% annually. There are 40 grams of substance present. How many will there be in 4 years? So again, it's decaying. So there's our one minus. It's the rate problem because they give us a percentage rate. If it said doubled or tripled, we wouldn't use this. But if they give us a percent, we use the formula. So we say our starting point of 40 grams. All right, 1 minus the rate of 0.05. Remember, it's 2 decimal places. And this one was easy because they just told us time period was 4 years. So we plugged in the calculator, 40 times the quantity 1 minus 0.05 to the 4th power, and it comes out to be a decimal. But since we're talking about grams, I just rounded it 32. Okay, 32 grams. All right. So now it's your turn. All right. Amy makes an initial investment of $5,000. The investment gains 13.5% each year. Find the amount Amy has at the end of 8 years. So the Ed puzzle is going to pause. You answer the question, and then you can check your answer on the next screen. All right, so I know it's a game because anytime you invest something, so we're going to take 5,000. It's 1 plus, so it's an increase. It'll be 0.135, and at the end of 8 years. So when I put $5,000 in, I get $13,770.09. All right, so money involved. We round it to the percent. I'm sorry, to the second decimal, $770.09. All I did is I put this in my calculator and I hit enter. All right, since this is not a real life thing, this is money. I want as much money as I can get. So there's the nonsense right there. Okay. Next one. The number of cats in the city is decreasing at a rate of about 0.5% every year. If in 1 year there are 3,300 cats in the city, how many will there be in 6 years? All right, you're going to have to think a little bit. This is a little tricky question, but I'll let it pause and let you answer the question. All right, so let's check it out. This one's a little tricky. It's still, we have 3,300 cats. It's a decay because they told us it's decreasing. They're decreasing, so it's 1 minus. It's 0.5%, so that's going to be 0.005 when I move it over 2 places to the left. And now my time period is going to be 5. The reason this is a tricky question is because in 1 year there were 3,300 cats. So that means that you take 1 away from the 6, and now we have 5. All right, so we still starting off at the end of that year, we have 3,300 cats. 1 minus 0.005 to the 5th power. I've got, since it's a real life cat, I rounded it down to 3,218 cats. All right. So then the next one, (2010), there were 25,000 birds in the forest. The number of birds are decreasing by 3% every year. How many birds should there be in 2020? All right, I'll let it pause and let you do it. So when we do this, again, same thing every time. Initial amount, 25,000. It's a decrease because the birds are decreasing, so it's a decay. 1 minus 3% is a decimal of 0.03. Now again, we never use years, we always use time periods. So in this case, there are 10 years from 2010 to 2020. So we're going to say 10 time periods. 25,000 times the quantity 1 minus 0.03 to the 10th power is 18,435. Again, I rounded down because we're talking about birds. All right. Doesn't take long. It's not going to be not difficult this week. So take your time, learn it, do well on the assessment, increase your grade, and um, we'll see you on Tuesday.